Good evening, children.
Good evening.
Good evening. Good evening, children. All right. So today we are going to see what a hollow cylinder is. So far we have come across some solids, namely cube, cuboid, and cylinder. So these are the solids we have seen so far in this chapter, mensuration. So now we're going to learn about a hollow cylinder. Hollow cylinder. All right. Let's first see how a hollow cylinder looks like. How does a hollow cylinder look like? Okay. Can you see this, children? Tell me, can you see this one? Can you see this object which I'm holding?
Yes, ma'am.
Yeah.
Yes.
So this can be an example of a hollow cylinder. So hollow meaning it's open at both ends. See, I can see through this. I can see through this object. Hollow meaning it's open at both the ends. You can see here, it's open from the top and the bottom. It's open. It is a cylinder. It is cylindrical in shape. Yes or no? Is it cylindrical in shape?
Yes, ma'am. Yes, ma'am.
Okay. Yeah, I'm having a sellotape roll in my hand. A sellotape roll in my hand. So this is one of the good examples of a hollow cylinder. Hollow because it's open at the top and from the bottom. And it's a hollow cylinder also because, see, hollow cylinder can be of two types. One hollow cylinder where it's open from the top and bottom, and the material it's made of is thin. That is the wall. This is called the wall of the cylinder. Okay, this wall can be very thin. Like if you make a cylinder out of paper, you pull out a paper from your notebook and you roll it. You can make a hollow cylinder, but there the wall of the cylinder is very thin because the thickness of the paper is very negligible. In that hollow cylinder, which is made out of a paper from your notebook, it's open at both the ends. That's why it's a hollow cylinder. And in that case, where a cylinder is made from a paper, the wall of the cylinder or the material the cylinder is made of is very thin. It's so thin that the wall is so thin, which is called the thickness of the wall, that is so negligible that it can be ignored, almost ignored. It's so small, it can be ignored. The thickness of the wall can just be ignored because it's so thin. The material, the paper is so thin. But in this case, this is also a hollow cylinder where the wall of the cylinder is thick. The wall of the cylinder is thick. So now we'll take up both the cases. Case one, where the wall of the cylinder, the thickness of the wall is so negligible that it can be ignored. That is the hollow cylinder made using a paper. Now, supposing you have this, a hollow cylinder made from a paper. Okay, and you have to paint. Please visualize. You have to paint this hollow cylinder from outside, not inside, only from outside. What is the situation? Notebook paper rolled to form a cylinder.
Paint the outer side of the cylinder.
One second. Yeah, thank you, Nandana. Just a second. So what is the situation? Notebook paper. You bring the ends together to form a hollow cylinder. You bring the opposite ends together to make a hollow cylinder. And supposing the task is to paint this hollow cylinder on the outside. You have to completely paint it on the outside. Or say, let's understand the complete thing. If you have to paint the hollow cylinder completely, you have to paint the hollow cylinder completely. Where all will we paint? We'll paint, so you'll get your paint, you'll get your brush, you'll paint the inside of the cylinder because you'll have to paint it all over. You'll have to paint it all over. So where all will we paint? This is the case where we have made the hollow cylinder using notebook paper or maybe newspaper. Any material where the material is very thin so that the thickness can be ignored completely. So in that case, where all can we paint? You can paint the inside curved surface area. You can paint the inside curved surface area and the outside curved surface area. Just imagine once you paint these two surfaces, you're done. That hollow cylinder which you have made using paper. You paint the inner CSA and you paint the outer inner CSA. This one is the inner CSA. This is the inner CSA. This one inside. And this is the outer CSA. This is the outer CSA. So you paint the inner CSA, you paint the outer CSA. Done. Done painting. Done painting. So the inner CSA of that cylinder will be 2 pi RH. You know, this is the formula to find the CSA of a cylinder, the curved surface area of a cylinder. The outer CSA also will be 2 pi RH. Because the two unknowns are radius and height. Radius and height. You know that the height of the cylinder is going to be the same. The inner height and the outer height is going to be the same. That's no different. So height will be the same whether it is the inner CSA or the outer CSA. What about the radius? Radius also is the same because the thickness is so negligible. It is ignored. So the inner radius and the outer radius will be the same. They'll be different only when the wall is thick. When the wall is thick, the radius will be different. We'll see now. That's the second case. When the wall is thick, when the material is thick, then there will be two radii, one inner radius and one outer radius. But when the material is very, very thin, the inner radius and the outer radius will be the same. The inner radius and the outer radius is the same. So case 1, hollow cylinder. Okay. Don't write case 1. When the thickness of the material is ignored. When the thickness of the material So when you make a hollow cylinder using paper and you have to paint the cylinder all over, if you have to paint the cylinder all over, then the two surfaces that have to be painted are the inner curved surface area and the outer curved surface area. You look inside the cylinder and paint inside, then outside. These are the two surfaces that you have to paint. Now in the formula 2 pi RH, the two values are radius and height. 2 and pi is a constant. 2 is a constant, pi is a constant. We have to fill in the values of R and H. R and H is the same whether it is inner or outer. The height is going to be the same, height of the cylinder. Radius is also the same because the material is so thin that the inner radius and the outer radius will be the same. So here the radius and height is the same. So whatever is the inner radius, the same will be the outer radius. So you can simply find the inner CSA and double it. You can simply find the inner CSA. The same value is the outer CSA. So you don't have to find it again actually. You can find the inner CSA 2 pi RH and double it. That will be the total. So if the inner CSA is some 100 centimeter square, then the outer CSA is also 100 centimeter square. You don't have to calculate again. It's 100. So the total area to be painted is 100 plus 100, 200. Is this much understood, children?
Yes, ma'am.
Yeah, please say yes or no.
Yes, ma'am.
Bhavishya, Nandana, and Swati. Got it?
Yes, ma'am.
Okay. Now, this is the next case. This is the next case where you make a hollow cylinder, say using a sheet of iron. A sheet of iron. Iron, you know.
Ma'am, I
Iron
have
is
a doubt, ma'am.
yes.
Ma'am, if the inner surface is thick, means how we can find the radius, ma'am? It will be different, ma'am.
If the inner radius is,
It has a thick.
that's the next case. That's the next case. That's what we are going to see now.
Okay.
Yeah. All right, children. So this is case one when the thickness of the material can be ignored. It's so thin, it can be ignored. Then the inner CSA and the outer CSA both are the same. Write down this one, children. Write down this. Please write down this. Done, children? Of course, square units. Square units. I'm sorry, square units. Square units.
Done, ma'am.
All right. So this is case two. This is again a hollow cylinder, case two. When the material, the wall of the cylinder, okay, when the material is thick. So you cannot, the material is thick, the material which the cylinder is made of is thick. The material with which the cylinder is made is thick. Like say you make a cylinder using a sheet of iron. Iron is a metal. A sheet of iron is thick and it's rolled. We cannot roll it, you know, we cannot do it. So say a sheet of iron is rolled to make a hollow cylinder. All right. So something like this. It need not be so wide, you know. It can be still thick also. Don't think the circle should be so wide. It can be really thick. It can be really very thick also. The inner circle can be very small because when it's very thick, the inner circle can be very small also. I just had this at home and I'm using this to explain a hollow cylinder. Okay, so now when you roll a sheet of iron to form a hollow cylinder, it looks like this. See, like I cut this open, it will be a thick sheet, right? If I cut this open, I use a pair of scissors and or something sharp and I cut it out. I cut and I spread it out. It look like a thick sheet of iron. If this material is iron, if I cut it and I open it. I open it. How will it look? It look like a sheet, a thick sheet of iron. If this material is iron. So a thick sheet of iron is rolled to make a hollow cylinder like this. So the wall is thick. So that means this here you can see a flat surface. You can see a flat surface here. And behind here also you can see a flat surface. You can see a flat surface. So that means there is one inner circle and there is one outer circle. And this is the area between the two circles. There is one inner circle. There is one inner circle inside, inner circle, and there is one outer circle. And between the two circles, see, there is one inner circle, there is an outer circle, And what you see here, what you see, this flat thing, no, is this one, this area between the two circles. This area between the two circles. This is what you see here. This flat thing, this flat thing, this flat thing. This flat thing is the shaded portion, is a shaded portion. So there is one inner circle, there is one outer circle because the material is thick. And this is the region between the two circles. That is what you see here, this flat thing. Similarly, you find the same thing behind. You find the same thing behind. Here. So this is how a hollow cylinder looks like when you make it out of a material which is thick, like a sheet of iron. Now, supposing you have to paint this one, this hollow cylinder, where the wall is thick. You have to paint this hollow cylinder where the wall is thick. Where all will you paint? You have to say it is, so you have to, now how is iron? Okay, what color is seen? Red color. So you'll have to paint this, hollow cylinder made of iron using red paint, red paint. All right. So now we start painting. We paint the inside, inner CSA. We paint the inner CSA. Then we paint the outer CSA. We are not done. Actually, when we do this, we are done in the case of a hollow cylinder where the wall is thin, so thin. But in this case, we are not still done. When you paint the inner CSA and when you paint the outer CSA, you can see that this flat portion is still in the color of iron. It's not red. This flat portion, you have to, there is area here to be painted. There is area here to be painted. You'll have to paint up this flat ring. This is called a ring. This is called a ring. That area between two circles is called a ring. The area between two circles, the two circles is called a ring. This flat thing. Okay. So you'll have to paint this portion, this ring. Similarly, you'll have to paint the ring behind here, this one. So there are totally four surfaces which have to be painted. In the case of a hollow cylinder where the wall is thick, you have to paint the inner CSA, you have to paint the outer CSA, you have to paint these two rings. So if you hold the cylinder like this, the ring on the top and the ring below. You'll have to paint the ring on the top and the ring below. Now when you do all this and you look at the cylinder, it's completely red. Nowhere you can see the, you can see iron. It's completely red. You can see the color of iron, I mean. It's completely red. You paint the inner curved surface area, the outer curved surface area, the flat portion on the top, which is a ring, and the flat portion below, which is another ring. When you paint all these portions, you're done. Now it's completely red. Now, this area between the two circles, how do we find the area between the two circles? Now, the inner radius is represented by the letter small r, and the outer radius. The outer radius is the radius of the outer circle. See, there are two circles. There are two distinct circles, two different circles. One inner circle you can see. You can see one inner circle. And then there is one outer circle. So inner circle will have a smaller radius. The radius of the outer circle is big. Inner circle is smaller. Outer circle, capital R. Why two different radius? Because the wall is thick. Wall is thick. Okay, so this is the edge of the inner wall, and this is the edge of the outer wall. Edge of the outer wall. So this portion, this is the flat portion on the top and bottom. This is the flat portion. So this is the inner radius. This is the inner radius, smaller, and from the center to this one is the outer radius. From the center to a point on the outer circle. From the center to a point on the outer circle is capital R. And from the center to a point on the inner circle is smaller. The center is common to both the circles. These two are concentric circles. They're concentric circles. They have the same center but different radii. These two circles are called concentric circles because they have the same center. They'll have the same center but different radii. So this is the center for both the circles. The inner radius is given by small r. The outer radius is given by capital R. So what are the, so let's again understand the four surfaces in a hollow cylinder where the material is thick. Hollow cylinder meaning you can see through the cylinder. It's open at both the ends. It's open at both the ends. So hollow cylinder. In hollow cylinder, the wall can be thin, so thin that it can be ignored. That thickness can be ignored completely. In which case, there is only one radius. There is nothing like inner and outer radius because you don't see two circles on the top. There's only one thin circle. You don't see two different circles. Only if you see two different circles, you can have one smaller and one capital R. No, where the material is thin, you can see only one thin circle on the top. So where the material is thin, there are no two circles on the top and bottom. So there's only one radius, which is smaller. And height, of course, is one height of the cylinder. There is nothing like inner height and outer height. There is inner radius. See, the two things are radius and height. There is something called the inner radius and outer radius, but there's nothing like inner height and outer height. See, what's the formula to find the curved surface area? 2 pi RH square units. 2 and pi are constants, radius and height. You can use the term inner and outer for radius and height. So you can say inner radius, outer radius, inner height, outer height. No, there's nothing like inner height, outer height. Both the heights are the same. That is the height of the cylinder. But there is definitely something like inner radius and outer radius. Because when there are two circles, one inside and one outside, when there are two circles, there is inner radius and outer radius. Inner radius for the inner circle, smaller, outer radius for the outer circle, capital R. That's when the material is thick. When the material is thin, there are no two circles, only one radius and one height. So when the material is thin, only one radius, one height. When the material is thick, we have inner radius smaller, outer radius capital R, but only one height, H, only one height H. Now so there are four surfaces. Talking about a hollow cylinder where the wall is thick, there are four surfaces to be painted. Okay, there are four surfaces. You can start painting from anywhere, but there are four surfaces. You can paint the rings on the top and bottom. You can start from anywhere. So maybe you start from here. This flat portion you paint. Is the object visible, children?
Yes, ma'am.
Yeah.
Yes, ma'am.
So you can, thank you. So you can start painting from anywhere. So you can paint this flat portion here, this flat portion here. Okay, then you can paint the other flat portion here. After painting these two flat portions, you can paint the inner CSA and then finally the outer CSA. So anyways, you'll have to paint four portions. Any order you can paint it. So where all you have to paint amounts to the area, the surface area. All right. Now, so when the material is thick, case 2, when the material is thick, hollow cylinder, when the material is thick, is thick. Now, when I'll come to volume, children. I'll come to volume. Let me first finish the surface area. So when the material is thick, let's talk about the curved surface area, the curved surface area. So the inner CSA, yeah, inner curved surface area, inner curved surface area is given by the formula. See, 2 pi RH is for curved surface area. 2 pi H is the same, small r for inner. For outer CSA, it will be 2 pi H is H only, but radius is capital R, square units. When it is inner CSA, use small r. When it is outer CSA, use capital R, square units. Square units. So this is about the areas of the inner and outer portions. Inner curved surface area, outer curved surface area. Curved surface area we've already seen for a cylinder is 2 pi RH. Use small r for inner, capital R for outer. Now what about the the rings on the top and bottom? Okay, so area of one ring. Area of one ring is equal to, how do we find the area of a ring? Okay, don't mind, it's not perfect. Please don't mind. So these are two concentric circles. These are two concentric circles, and this is the ring. What I've shaded is the ring. So from here to here is smaller, and from here to here, that is from the center to a point on the inner circle is smaller. From the same center to a point on the outer circle is capital R. Capital R. Now you know that area of the ring is area of the outer circle minus the area of the inner circle. How do you find the area of the ring? Area of the inner circle. Area of one ring is equal to area of inner circle. Area of inner circle, think about it. Area of inner circle. Oh, sorry, outer circle. I'm sorry. Area of outer circle minus area of inner circle. Area of outer circle minus area of inner circle. Area of inner circle. Area of one ring, or you can just say area of ring. You can just say area of ring, area of a ring. Okay, is equal to area of the, because how do you now see here, children? You would have learned this in standard 7. Now see if there's a rectangle like this and a rectangle like this. Supposing the dimensions of the outer rectangle are say like 20 here and 10 here, and inner rectangle say is 10 and 5. What's the area of this one? What is the area of this portion? How do you find the area of the shaded region, children? In the case of the rectangle, there is one rectangle inside another.
Ma'am, it is
What is it?
the
Area
inner
in
rectangle.
outer rectangle minus area of inner rectangle.
Yeah, correct. The area of the shaded region is area of the outer rectangle. What is the area of the outer rectangle?
5.
I'm L into B.
Yeah, what's the value? What's the answer? Yeah, what's the area of the outer
200.
rectangle? 200 square units. Yeah, so 200. The area of the outer rectangle is 200 square units. The area of the inner rectangle is 10 into 5, 50 square units.
50.
So 200 minus 50. The area of the shaded region is 150 square units. Am I clear, children?
Yes, ma'am.
Yes, ma'am.
Okay, no, all of you can hear me clearly?
Yes, ma'am.
Yes, ma'am.
Okay.
You're audible, ma'am.
Okay, okay. So area of a ring is, oh sorry, so in the case of one rectangle inside the other like this, the area of the shaded region is the area of the outer rectangle minus the area of the inner rectangle. Similarly here, you can see a similar situation here, but there are two circles, one circle inside the other. So the area of the shaded region is area of the outer circle minus the area of the inner circle. You can relate it, no? You can relate these two. Like how there it was area of outer rectangle minus area of inner rectangle. Here the area of the shaded region is the area of the outer circle minus the area of the inner circle. So area of outer circle is pi capital R square minus area of inner circle is pi small r square. You can take out pi common and write r square minus r square square units. This is the formula to find the area of a ring. Ring is the area between two circles. Between two concentric circles, the area in between two circles, is the ring. Area of a ring is area of the outer circle minus the area of the inner circle. Outer circle, see area of circle we know pi r square. The formula to find the area of a circle is pi r square. Outer circle pi capital R square. Inner circle pi small r square. Pi capital R square minus pi small r square is the area of the ring. And you can take pi common, and in bracket you have r square minus r square square units because area. So this is the area of one ring. What will be the area of two rings? Multiply this answer by 2. See, there is one ring here, there's another ring here. Same similar ring here. So 2 rings will be multiply this answer by 2. Or you can say 2 pi capital R square minus small r square. Area of two rings. Area of 2 rings, you know. You can even say is equal to 2 pi. 2 into, you're doubling it. Like if 1 is 5, 2 will be 2 into 5. Similarly, 2 into pi r square minus r square. Square units. So if you're asked to find, in this case where the material is thick, if you're asked to find the area to be painted in a hollow cylinder, you have to separately find the inner CSA, find the inner CSA, find the outer CSA, find the area of the ring on the top and double it, and double it. Add all these answers. Add all these areas. Inner curved surface area, outer curved surface area of two rings. Add all these three. That will give you the total area to be painted, or the total surface area of a hollow cylinder. Whatever is painted is only the surface area. So the total surface area of a hollow cylinder is equal to inner CSA plus outer CSA plus area of two rings, one on the top and one below. Is that clear, children?
Ma'am, I can understand the pi of r square minus r square, ma'am, but I can't understand 2 pi into r square minus r square.
No. So area of one ring is pi r square. Okay, this is the area of one ring, right? Pi r square minus r square is the area of one ring, right?
Yes, ma'am.
Now there is one ring on the top and a similar ring below, right? A similar
Yes,
ring
ma'am.
below. So now supposing, okay, so it is pi r square minus r square plus pi r square minus r square, right? This you understand?
Yes, ma'am. Yes, ma'am.
Now what is 5 plus 5? 5 taken to 5 added to itself. 2 into 5, right?
Yes, ma'am.
Repeated addition is multiplication. 5 plus 5 means 2 into 5. Similarly, the same thing, pi r square minus r square plus pi r square minus r square is 2 into pi r square minus r square.
Yes, ma'am. Understood.
It is doubling that answer. Two rings will be one ring, whatever is for one ring, multiply by 2, you'll get for two rings. No, still
Yes,
not
ma'am.
clear? I can tell you
Yes, ma'am.
again. Okay.
Understood, ma'am.
Okay. Yeah, please write down this, children. Please write down this. Visualize the object. If you can, I'll be very happy if you, I'll just give you 3 minutes time. If you can just go around your house and find something which can be a good example of a hollow cylinder. Get, maybe if you have, young ones at home, their toys, something may look like a hollow cylinder. Or if you play with wooden blocks, just check if you can get Done, children?
Yes, ma'am, done.
All right. So I'm not giving you, I have not given you one formula for the total surface area. So if you have to find the total surface area, you find the inner CSA, find the outer CSA, find the area of two rings, and add all these answers to get the total surface area. Now coming to the volume of the material. Now see, now such a hollow cylinder cannot hold any liquid because it's open at both the ends. A hollow cylinder cannot hold any liquid. Okay, but so there is no capacity here because nothing can be poured into it. But there's definitely volume of the material used. Now, when the material is iron, it can be wood, it can be made of wood, iron, some thick plastic, whatever. So definitely the material used has area and volume. Now, if iron is the material used, area is whatever you can paint. That's the area. That's what we have understood now. Now, the same iron material has volume. How do you find the volume of the material used? Please get it clear. The hollow cylinder we are talking about is made of a thick sheet of iron, which is a metal. So now we understand that the hollow cylinder is open at both the ends, so it cannot hold any liquid. Capacity, no, is completely absent because it cannot hold any liquid. But the material iron has both volume and area. Area we understood now. Volume. What's the volume of iron? How much of iron? How much of iron? The surface area of iron we found. How much iron is there? What's the quantity of iron? How many grams? How many kilograms? So that quantity, that volume. What's the volume of iron in the hollow cylinder? So for that, I'll clear the screen, children.
Yes, ma'am.
Okay. So it's a continuation. So volume of material in the hollow cylinder, is equal to cylinder. 1 minute, I'll write the same thing. Volume of material used to make the hollow cylinder, the hollow cylinder is equal to area of, that's what we know, area of uniform cross section into height. Now the cross section of a hollow cylinder, here the cross section of a hollow cylinder is a ring. The cross section of a hollow cylinder is a ring. This flat thing, this is the cross section, is a ring, this flat thing. This is the cross section. So if you have many plain that is, if you have cutouts of rings made of paper, okay, you have cut many rings using a paper. If you stack them, you have many identical rings which you have cut using paper. If you stack them one over the other, you will get a cylinder like this. You will get a hollow cylinder like this. If you have identical rings, what's a ring? A ring is something that looks like this. That is, you have a circular paper, and from that if you cut off, if you take away, if you remove a circle from the middle, what is left is the ring. Imagine that. You have a circle like this, made of paper. Now here, you cut a circle from the middle. 1 minute, I'll just try to get that for you in a paper. Just a second. Children, see, I have not used a scissor. I've just cut using my hand, so it cannot. You can get an idea, definitely. Can you see?
Yes, ma'am.
Yeah, see, what have I done? See, this is I made this from a paper. You can see the outer circle. You can see the inner circle. 1 minute, I think it's, yeah. Can you see the outer circle and inner circle?
Yes, ma'am.
So like this, you have identical cutouts like this. From paper, using paper, you've made many rings like this. This is a ring. See, there is no paper in the middle here. This is a ring. Now you have many paper cutouts like this. You stack them, you keep them, you place them like this to some height. It's paper, so you stack it to some height. You have many pieces like this, identical pieces. You place it one over the other. What you will get will be a hollow cylinder. You have to visualize that, like how we understood when we stack many rectangles. When you stack rectangles, the solid obtained is a cuboid. Similarly, when you stack identical rings like this, when you place many of this one over the other, what you get is a solid, which is a hollow cylinder. So the cross section of a hollow cylinder is a ring, and the area of a ring is pi r square minus r square. So area of the uniform cross section, we just understood this is the ring. The area of this portion is pi r square minus r square. So that's the area of the cross section. Area of sorry, I cleared it by mistake. I'll write it again. Volume of material used to make whatever, okay, a hollow cylinder. Volume of material used to make a hollow cylinder, or volume of material in a hollow cylinder. Okay, is equal to volume is area of uniform cross section. Area of uniform cross section into height. This is how we have understood volume. Area of uniform cross section into height. The cross section is a ring. The cross section is a ring. So area of a ring into height. Area of the ring is pi r square minus r square into height, which is h. Height of the cylinder is h. So that is pi r square minus r square into h. So you can just write h like this. Cubic units. Volume, so cubic units. So pi capital R square minus small r square in a bracket into h. Or you can also write it like this, pi h. You can also write pi h into capital R square minus small r square. Both are the same. Cubic units is the formula to find the volume of the material in a hollow cylinder. It has no capacity because it cannot hold any liquid. But what's the volume of material? How much kg of iron is used? 1 kg, 2 kgs, 3 kgs. How much iron is used to make the hollow cylinder? That's the volume of the material, which can be found using this formula. So you will find it in cubic units. Then you can convert it to kgs and grams. Some other information will be given in the question. Then using this volume, you can convert that to kilograms or grams. For that, some other information will be given in the question. Am I clear, children?
Yes, ma'am, clear.
Yeah, please write down, children. Please write down. So today, actually, I was in a webinar from 5 to, I thought it will get over at 6:30. There was a webinar on Vedic maths, so I'm planning to learn Vedic maths. So I was attending that webinar. I thought it will finish by 6:30. But then it ended only at 6:45. That's why there was a delay in starting the meeting. Okay, children. And again, I have another, webinar at 8 o'clock, 8 to 9:30, 9:45 today. So I cannot compensate for that 15 minutes delay in starting today's meeting. I was supposed to start at 6:30 and end at 8. I'll be ending at 8 today, but that 15 minutes I'll compensate in the next class. Friday we'll have class from 7:15 to 8:45, right? So maybe that day I'll make it from 7 to 8:45. I'll compensate for the 15 minutes in the next class. I hope all of you understand that. So today's class I have to end by 8 o'clock. Yes, Dylan, please write. Anybody here knows Vedic maths? Swati, Bhavishya, Nandana? Any of
No,
you have learned Vedic maths?
No, ma'am.
No? Okay. Done writing, children?
Yes, ma'am.
Okay. All right. Yeah. So now we are ready to get started to answer questions on a hollow cylinder. So we have seen two cases. One hollow cylinder where the wall is very thin. So there the inner CSA and the outer CSA both will be the same. Why? Because radius and height is the same. Inner radius, outer radius, both are the same. So when the wall is very thin, the material is very, very thin, so negligible, the inner CSA and the outer CSA will be the same. There will be no ring on the top and bottom. That's the difference. When the material is very, very thin, there is no ring formed on the top and bottom. Just a second. See here, I'm making the cylinder. So this is a piece of paper. A piece of paper. I'm, bringing the ends together and forming a cylinder. I'll stick it up. So can you see the cylinder? 1 minute. You got an idea now how to make the cylinder. It's blurred, right? You cannot see it clearly, right?
Yes, ma'am.
Yeah, that's because of the light falling on the paper. Okay, so you understand how to make a cylinder. You just have to roll and bring the ends together. This is a piece of paper. This is a piece of paper. So just roll it. You can roll it anyways. So see here, I'm just rolling it like this along the breadth. I'm rolling it and I get a cylinder. And this cylinder is a hollow cylinder. Where the wall is very thin. It's a hollow cylinder. See, I can see through the cylinder. I can see through the cylinder. So here, this is an example of a hollow cylinder where the material is very thin. So there is no ring formed on the top. You make a cylinder using a paper later. There is no ring formed on the top. A ring is formed only when there are two distinct circles, two different circles. When there is a circle, outer circle like this, and there should at least be another circle like this, at least like this, another circle like this. Then between the two circles, you can see the flat ring between the two circles. But when you make a hollow cylinder using a paper, there's only one circle on the top like this. So there is no ring which is formed. There's no ring formed. So in that case, the total area to be painted is inner CSA plus the outer CSA. Inner CSA plus outer CSA. No ring on the top. That's the difference. When the material is very thin, where you should paint inner CSA, outer CSA. That's all. Inside and outside. That's it. But when the material is thick, you'll paint inside, you'll paint outside, and you'll paint the two rings. That is the difference. All right, children. I told you about volume also. Yeah. Now let's answer this question. The outer and inner diameters of a hollow pipe. Whenever they say outer and inner diameters, the pipe, the material is thick, because that is why they've given two diameters. That's why they've given. Now this hollow pipe, is the wall thick or thin? It is thick. That is why they've given two diameters, which means we have one small r and one capital R. The length of the pipe is nothing but the height of the pipe. The length of the pipe is nothing but the height of the pipe. What is the volume of the material in the pipe? What is the volume of the material in the pipe? So we have a formula. What is the formula? We understood the formula also. We're not just memorizing it. So what's the formula? Before you write the formula, let's, what is the value of the outer diameter? Outer diameter?
2.2
2.2 centimeter.
2.2 centimeter. So what is the outer radius? Outer radius?
2 centimeter.
1.1. 1.1 centimeter.
1.1 centimeter. What is the, so like this, you'll have to write out. The answer is in the next slide. So then the inner diameter and the inner radius. Then the height is 28. How will you find the volume? What's the formula?
Ma'am, area of uniform
Pi h of
No, that last step you should say. Pi h into capital R square minus small r square. You don't have to write area of uniform cross section. All that is just for us to understand. Formula is that last expression. Pi h into capital R square minus small r square. Or you can say pi r square minus r square into h, whatever. That's all. So you have the two r's. You have two diameters given here, the inner and outer. From that you can find inner radius and outer radius, and you have the height. So just put the values in the formula and find the volume. I'll show you the answer slide, children. Please understand and write down. I've represented the outer diameter using capital letters, inner using small letters. Outer using capital letters, children. See, outer diameter, capital D. Outer radius, capital R. Outer using capital letters, inner using small letters. So inner diameter, small d. Diameter, no, so small d. Inner diameter, small d. Inner radius, smaller. Outer capital, D and R. I've used D for diameter, R for radius. And the height, which is h, 28 centimeters. Yes, children, you can understand. Start working. You must write those values first. First, you must write all this. You must write all this. You must write the values of R, R, and H. Then you should use that in the formula. Done, children?
No, ma'am.
Okay. Is the concept clear, children, please? Because this is not only in 8th standard. You will see this in 9th and 10th. Very important.
Ma'am, I'm having doubt.
Okay.
Ma'am, I'm having doubt.
Yeah. Oh, yes, ma'am.
Ma'am, after 27 into 28 into 1.1 square minus 1 square, after that step, you wrote like 1.21 minus 1, like that you wrote, ma'am.
Correct. I have to explain that. Yeah. So 7 ones are 7, 7 fours are 28. Correct?
Yes, ma'am.
So 22 into 4. Now 1.1 into 1.1 square means 1.1 into 1.1. What is 1.1 into 1.1? So that's nothing but 11 into 11. 11 11s are 121. And you should place the decimal point. See here, 2 places. So after the decimal point, there should be 2 digits. So 1.21. I'll tell you again. See here, 1.1 square means 1.1 into 1.1, which means 11 into 11. 11 11s are 121. Now we have to, after the decimal point, there should be 2 digits because you have 1, 2. So after the decimal point, there should be 2 digits. So 1.21 is answer, 1.21. 1 square is 1. Now 1.21 minus 1 is 0.21. Yes, Bhavishya?
Yes, ma'am, understood.
Okay.
Done, ma'am.
Very good. Children, please ask me your questions. Nandana and Swati, any doubts?
No question. I've understood.
Nandana, you're doing maths or you're doing a school homework, Nandana?
No, ma'am, that volume of material, I will take a screenshot first.
What?
But I was telling that you are telling woman how volume of that material of hallows ma'am. I didn't write, I forgot to write, but I took a screenshot. Now I'm ready.
Oh my God. You want me to write that again? Okay. No, Nandana, now how will you manage? You didn't write the full thing, huh, Nandana? Unmute.
I took a screenshot.
Oh, okay. Please complete it. Very important it is. Okay. All right. So we'll go to the next one. So how did I simplify this? 7 ones are 7 fours are. So 22 into 4. Then 1.1 square is 1.21. 1.1 into 1.1 is 1.21. 1 square is 1. Then when you subtract, you get 0.21. 88 into 0.21, just regular multiplication. 88 into 21, you get 1848. And then 2 decimal places here, 1, 2. So here, 18.48 centimeter cubed because volume. All right, next question. See here. I told you can convert the volume in centimeter cubed or meter cubed to grams or kilograms. And for that, some other information will be given on the question. So see here, what is the weight of the cylinder if the metal weighs 8 grams for every centimeter cubed? So such an information will be given in the question. Then you can convert the volume in centimeter cubed or meter cubed to grams or kilograms. This information will be given in the question. What will be the weight of the cylinder if the metal weighs 8 grams for every centimeter cubed? 1 centimeter cubed of metal weighs 8 grams. Okay, so for that you'll have to find the volume and multiply by 8, because see your children, just imagine that the cylinder which you have. Please focus, that's very important. Hollow cylinder, material is thick. The volume of this hollow cylinder, okay, it's made of some material. The volume of the material in this hollow cylinder, say, is 10 centimeter cube, for example. It's 10 centimeter cubed. The volume of the material in the hollow cylinder, say, is 10 centimeter cubed. We have found this using the formula pi h into capital R square minus small r square. Using this formula, we substituted the values and we calculated, we got 10 centimeter cubed. Now, this is the volume of the material in the hollow cylinder. If we have to find the weight, how will you find the weight? It's given there. 1 centimeter cube has a weight of 8 grams. So 2 centimeter cube will have a weight of 16 grams. 3 centimeter cube will have a weight of 24 grams. So 10 centimeter cube will have a weight of 8 into 10, 80 grams. It's very simple, children. Like for 1 centimeter cube, the weight is 8 grams. So for 10 centimeter cube, the weight will be 10 into 8, 80 grams. Yes or no?
Yes, ma'am.
Correct. Every centimeter cube of metal has a weight of 8 grams. So 10 centimeter cube of metal will have a weight of 10 into 8, 80 grams. So see, we've converted the volume in centimeter cubed to grams with the help of this extra information given in the question. Yes, now you can work. You read the question for yourself. Complete this. Please go through the answer, children. I think I'll ask you to take a screenshot and complete it. I told you I have another webinar to join at 8 o'clock. Go through the answer and take a screenshot. You can complete it. Okay, so this is a different information. I did not read the question, so I have to tell you this. Listen to me, children. Okay, now listen to me. There's a different information here. Okay, all right, children. Listen to me, children. Now this is the inner radius. This is the outer radius. Okay. Now what is here is called the thickness of the material, which is given by the letter W. The thickness of the material is given by the letter W. The thickness is given by the letter W. Now children, now tell me, capital R is nothing but small r plus thickness. You can visualize it. There's nothing to memorize here. Just visualize it. I'll draw it again for you if you want. See here. Outer circle. Inner circle. From here to here is inner radius. Yes or no?
Yes, ma'am.
Now, this is called the thickness. From here to here is the thickness of the material, which is represented by the letter W. Okay.
Yes, ma'am.
Now, what is R plus W? Isn't it capital R? Isn't it the value of capital R?
Yes, ma'am, it is.
Because it is from the center to a point on the circumference of the outer circle. So capital R is equal to small r plus the thickness. Now, next thing, what is small r? Now, you know that this from here to here is capital R. From here to here, this full thing is capital R. Is capital R. Now, from capital R, if you take away the thickness, if you remove this thickness, if you subtract the thickness from capital R, if you subtract the thickness, won't you get smaller? Okay, I'll draw it again. 1 minute. I'll use a different way to draw. 1 minute. See here. All right, children. Now, please tell me, capital R is equal to, see from here to here is small r plus the thickness. Is this understood? Plus the thickness. Is this understood?
Yes, ma'am.
Now, see here. Small r is the capital R. This from here to here, it's the capital R. See, from here to here is capital R. So from capital R, if you take away the thickness, see, I'm taking away the thickness now. I'm subtracting the thickness. See, I'll take away the thickness. I'll remove this. So from capital R, if you take away the thickness, don't you get smaller? See here, this full thing from here to here is capital R. From that, I removed the thickness. I took away the thickness. See here, smaller. So the small r is capital R. Outer radius minus the thickness. Outer radius, from the outer radius, if you subtract the thickness, you will get the inner radius. And the thickness is given by capital R minus small r. Thickness. What is the thickness? The capital R. Outside radius minus the inside radius will be the thickness. Thickness is equal to capital R minus small r. So this is how these three quantities are related. Tell me. Capital R is equal to inner radius. Outer radius is equal to inner radius plus the thickness. Inner radius is equal to outer radius minus the thickness. And the thickness is outer radius minus inner radius. Please make a note of this. Since there's no time, maybe I'll repeat it in the next class. Please make a note of this.
Finished, ma'am.
Swati?
Done, ma'am.
Okay. Now, children, in this question, you are given the thickness, that is W. Thickness of a hollow metallic cylinder is 2 centimeters. That is W is 2 centimeters. This is W. See here, I've written here W is 2 centimeters. It is 70 centimeters long. That means the height is 70 centimeters. Height is 70 centimeters. Outer diameter is 28. Outer diameter, see your outer diameter, capital D is 28. That means what is the outer radius? 14. Half of that, 14. From outer diameter, you can get the outer radius, 14. Now you should find the inner radius. How do you find the inner radius? Inner radius is this one. Outer radius minus the thickness. So 14 minus 2, just 12 centimeters. To find volume, children, we need three things: H, R, and R. To find volume, you need the value of capital R, small r, and W. Outer diameter is given, so you can get the outer radius, capital R. Thickness is given. So using this formula, R is equal to R minus W, you can find the inner radius, 12. Height is 70 centimeters, it's given in the question. This is the formula to find the volume. Substitute the values and find the volume. Then it's given 1 centimeter cubed is 8 grams. So 11,440 centimeter cubed will be 11,440 into 8. So it will be 91,520 grams. But since it's more than 1,000 grams, you divide by 1,000 to convert it to kilograms. How do you convert grams to kilograms? Divide by 1,000. When you divide by 1,000, it's converted to kilograms. And that's nothing but 91.520 kilograms. Children, please take a screenshot, complete this. We can discuss the answer again in the next class. Please work it. Take a screenshot and complete it, children.
Yes, ma'am. Took, ma'am.
Done? All of you?
Yes, ma'am.
Took screenshot.
All right, ma'am. All right. Thank you, Nandana, Swati, and Bhavishya. That's it for today's session. You may leave the call. Thank you.
Thank you.